In the summer of 1816, winter came back. Snow fell in June, rivers froze, crops failed across entire regions. And across the world, people were asking the same question. What was happening to the weather? The answer lay thousands of kilometers away. And its effects would lead to famine, drive migration, fuel unrest, and even help inspire one of the most famous monsters ever created. This wasn't an isolated stretch of bad weather. Across Europe, North America, and parts of Asia, the season seemed to be breaking down. But the cause wasn't in Europe, North America, or Asia. The story of 1816 actually begins a year earlier, on a remote island in what is now Indonesia. Mount Tambora dominated the island of Sumbawa, rising more than 4,000 meters above the sea. Then, something changed. Rumbles began coming from deep inside the mountain. Dark clouds appeared near its summit. Tambora was showing signs of life. On April 5th, 1815, the first major eruption began. The explosions were so loud they were mistaken for cannon fire on islands hundreds of kilometers away. British authorities, fearing an attack, reportedly sent forces to investigate. But that was only the warning. 5 days later, on April 10th, Tambora erupted again, this time with almost unimaginable force. Columns of ash and gas shot high into the atmosphere. Superheated flows raced down the mountainside, destroying settlements in their path. Ash buried the surrounding landscape, while debris crashing into the sea helped generate tsunamis that struck nearby islands. And Tambora itself was transformed. More than a kilometer of mountain disappeared, leaving behind an enormous crater roughly 6 kilometers across. Thousands were killed during the eruption, with many more dying afterward from starvation and disease. Today, Tambora's eruption is classified as a VEI 7, one of the largest volcanic events humans have ever recorded. But the eruption hadn't only devastated the land around it, it had also injected an enormous amount of material high into the atmosphere. And that is where the story of 1816 really begins. The key wasn't the lava, or even the ash. Tambora had released an enormous amount of sulfur dioxide high into the atmosphere. There, it reacted with water vapor to form tiny droplets known as sulfate aerosols. Unlike most volcanic ash, which falls relatively quickly, these particles can remain in the stratosphere for months or even years. And they do something remarkably simple. They reflect a portion of the sun's energy back into space. Think of it as placing a thin, almost invisible filter around the planet. Less sunlight reaches the surface, and temperatures begin to fall. Tambora's eruption contributed to a drop in global average temperature, estimated at roughly 0.5 degrees Celsius. That doesn't sound like much, but a global average can be deceptive. In some regions, the changes were far more severe, disrupting rainfall, shifting weather patterns, and shortening growing seasons. The seasons hadn't disappeared, but in parts of the world, they no longer seemed to arrive when they were supposed to. By the spring of 1816, the strange weather was becoming impossible to dismiss. In New England, temperatures swung widely. Warm days could be followed by sudden frost, destroying crops almost overnight. Then came June. Snow fell across parts of the northeastern United States and eastern Canada. In Vermont, snowfall reportedly left drifts more than a foot deep. Farmers replanted their fields, only to watch the cold destroy them again. The consequences quickly reached the dinner table. As harvest failed, the price of staples such as grain soared. Some families abandoned their farms altogether, joining a growing migration west towards the American interior. Across the Atlantic, Europe's version of the crisis looked different. Not snow, but relentless cold and rain. Fields flooded, grains rotted. In Ireland, weeks of heavy rainfall devastated crops, while food shortages helped create conditions for famine and disease. Central Europe was hit particularly hard. As food prices climbed, desperation spilled into the streets. But the disruption extended far beyond the Atlantic world. In China, unusually cold conditions damaged crops, with snow and frost reportedly unusually far south, while changes to the Asian monsoon brought drought to some areas and flooding to others. Korea also experienced colder temperatures and unusually heavy rainfall, but remarkably, its rice harvest didn't collapse. The additional rain actually helped produce a bumper crop in 1816. The weather wasn't identical everywhere, and that was precisely the point. A shift in global climate could mean snow in one place, endless rain in another, drought somewhere else, and even surprisingly good harvests somewhere in between. For the people living through it, there were no satellites or global weather maps showing how these events fit together. They simply knew that something had gone wrong with the seasons. The eruption also left its mark in places you might never expect. Across Europe, volcanic particles produced unusually vivid sunsets, brilliant reds, oranges, and purples that appeared in the work of painters of the period. And perhaps the most famous cultural legacy emerged beside Lake Geneva in Switzerland. That summer, Mary Shelley, Percy Shelley, Lord Byron, and physician John Polidori had gathered there expecting to enjoy the outdoors. Instead, the relentless rain repeatedly kept them inside. To pass the time, Byron proposed a challenge. Each of them would write a ghost story. Polidori eventually produced The Vampire, an early landmark of modern vampire fiction. And 18-year-old Mary Shelley began developing an idea of her own, a scientist who discovered how to bring the dead back to life. That idea became Frankenstein. Even Byron's writing reflected the atmosphere around him. That summer he wrote Darkness, an apocalyptic poem imagining a world in which the sun had gone out. None of these events happened because of Tambora alone, but the eruption didn't need to create history from nothing. It changed the conditions under which many people made history. Tambora was extraordinary, but it wasn't the first eruption to disrupt Earth's climate, and it wouldn't be the last. In the year 536, writers across the Mediterranean described something deeply unsettling. The sun seemed to lose its brightness. Temperatures fell, harvests suffered, and tree rings show that this marked the beginning of one of the coldest periods of the last 2,000 years. Ice cores point towards major volcanic eruptions. Although exactly which volcano triggered the initial crisis remains uncertain. Then, only a few years later, the Justinian plague, began devastating populations across the Mediterranean world. Some have even wondered whether memories of environmental catastrophes from this period eventually influenced later European legends of barren kingdoms and the wasteland. It's an intriguing possibility, but impossible to prove. Then in 1257, another enormous eruption occurred much closer to Tambora, Mount Samalas, on the Indonesian island of Lombok, erupted with the same VEI 7 classification Tambora would receive centuries later. Evidence of that eruption has been found in ice cores from both Greenland and Antarctica, and it contributed to significant global cooling. Then came Tambora in 1815. Just 68 years later, Krakatoa exploded, again in Indonesia. Its eruption produced spectacular sunsets around the world and another period of measurable cooling. And then, in 1991, Mount Pinatubo erupted in the Philippines. This time, satellites were watching. Scientists tracked its sulfur cloud as it spread throughout the atmosphere and measured the cooling that followed. For the first time, humanity could watch in real time the same basic process that people in 1816 had experienced without understanding. From mysterious darkened skies in 536, to evidence frozen inside ancient ice, to satellites watching volcanic clouds circle the planet, we now understand something the people living through the year without summer couldn't. A volcano doesn't have to be nearby to change your world. Today, climate change is once again at the center of political and scientific debate. Most of that conversation focuses on us, fossil fuels, greenhouse gases, and the effect human activity is having on the planet. But 1816 reminds us that humanity is only one part of a much larger and more volatile system. Earth's climate was changing long before we began burning fossil fuels. Volcanoes, changes in the Earth's orbit, variations in solar activity, and shifting ocean currents have all pushed the planet towards warmer and cooler periods throughout history. What makes Tambora so remarkable is how little warning there was. One eruption on a remote Indonesian island temporarily altered the climate across enormous parts of the planet, and the temperatures didn't need to change by very much. A shift in roughly half a degree in global average was enough to disrupt growing seasons, destroy harvests, increase food prices, encourage migration, and alter the decisions of millions of people. Today our civilization is far more technologically advanced than it was in 1816. But it's also far more interconnected. Our food, energy, transportation, and economies depend on enormous global systems functioning together. And perhaps that's the lasting lesson of the year without summer. We spend a lot of time debating how much control humanity has over climate. But sometimes it's worth remembering just how much control the climate has over us. So here's my question for you. If another Tambora-sized eruption happened tomorrow, do you think the modern world would be able to handle it better than the people did in 1816? Let me know in the comments. And if you enjoyed the video, consider dropping a like and subscribe. As always, thanks for watching, and I'll see you in the next one.